If you're like me, in the year 2000, you were somewhere in America in a pool with your family. Meanwhile, across the world, Teamwood Games was running around Denmark, building up their skills, while the farm animals of the world sat doing farm animal stuff, getting ready to inspire the greatest game ever created. But there's more to this story, and there was more going on in the year 2000. Back in 2000, while I was still sucking on baby bottle pops, the team of Nintendo of Japan was working on releasing one of the most impressive handheld devices we've ever seen. The GBA's 16 MHz processor, quarter megabyte of RAM, and 2 AA batteries made it a technical powerhouse. Even as a kid, I dreamed of making my own games, but it wasn't until decades later that I saw the perfect opportunity to bring a new experience to this console. In September of 2021, Super Auto Pets was released, and literally my immediate reaction was, this should be a Super Nintendo game.
Super Nintendos neuester Hit heißt Zelda und der reißt mächtig mit. Abenteuer, Action, schwarze Magie, Drachen und Monster und...
As I thought about it, it became clear that although making a Super Nintendo game would have been fun, it just felt like the right fit for the Game Boy Advance. So what do I have to do to actually make this game? But first, we have to make graphics, obviously. Good thing, I have a mouse and a copy of Sprite, so we're covered there. We need to learn to write code for the Game Boy Advance, and I have a text editor and a tutorial that was written 19 years ago and last updated a decade ago, so we're good there. Then we need to think about music. I have a girlfriend who's a musician. So we're gonna get something. And then lastly, we gotta figure out the actual game engine and the logic involved. And luckily, I misspent my youth and stayed inside and learned to write code. So we should be A-okay. With that loosely formed plan, we're almost ready to forge ahead. But before we do that, let's talk a little bit about Super Auto Pets as a game, so we're on the same page about what we're trying to build. Super Auto Pets is 2 teams of up to 5 pets fighting head to head. The animals can have special abilities so they can damage opponents or send stats to their teammates, but it's basically about setting up your team in the correct way so that your pets play off of each other and win most of the time. You're given 5 lives to try to get 10 wins against a random assortment of other teams, and then every few turns, new, stronger animals are introduced into the store. And in that store is where the majority of the gameplay happens. You're reorganizing animals, stacking your existing ones to upgrade them, or buying shields or other items to help improve their chance of winning. Super Auto Pets has this amazing visual style that's like cute and charming, and we want to make sure we bring that over to the Game Boy. So we're going to start there with Chapter 1, Graphics. The first hurdle we have to overcome is looking at the actual resolution of the Game Boy screen. At 240 by 160, it's a similar aspect ratio to a normal computer monitor, but we're working with a much smaller number of pixels, and if you're holding a Game Boy in real life, that screen is going to be quite small, so our graphics have to be bigger and bolder than they would be on a high-resolution screen. As a base to get started, I went and took a screenshot of Super Auto Pets and scaled it down to a Game Boy's resolution just to see how it felt. And it was actually really promising. Every part of it will need to be redrawn, but we can already kind of start to imagine what this is going to feel like once we redraw all that art. The Game Boy Advance isn't actually fast enough to change every pixel on the screen every frame. So to get around that, it uses a tile-based system, which allows the Game Boy hardware to more efficiently draw an entire screen worth of images. As I went to redraw the background, I started making tiles and reusing those tiles wherever I could to ensure that as much of the image was a duplicate of itself as possible without making it look like it was a bunch of the same image. Once the background was done, I moved on to drawing all the animals. Most of the original pets in Super Auto Pets were from open source emoji sets, so it was really easy for me to go find the original art for each one, then I can take that into Sprite, scale it down, use it as a reference to draw something that's a bit more bold and fits within the very low resolution and limited color palette that we had. And then we just had to do that 80 more times, and we ended up with this nice little sprite sheet. But actually, we ended up with 2 nice little sprite sheets. Can you tell the difference? I'll give you 3 seconds. I don't know if that was 3 seconds. The sprite sheet on the left uses about 300 different colors, and the sprite sheet on the right uses about 50. The Game Boy Advance has a limitation that sprites can only use about 256 colors at a time. So I went through and I reduced down that palette by merging similar colors. And I ended up with what I think is an even better looking result that does interesting hue variations and things like that I would have not thought of had I not went through this extra process. The final graphical element we need to address is the UI components. If we go back to our shrunk down Super Auto Pets UI, you can see the numbers are some of the hardest stuff to read. And this is going to be even worse on a low contrast Game Boy Advance screen. So I redrew this and I made the numbers larger as a ratio to the animals. And then I also went and added the L and R UI components so that we can see that those buttons have an action. And that's pretty much it. We can take this and move on to our next chapter, GBA Code. I chose to write this game in pure C, and it's a very different experience building a Game Boy game compared to building a game in Unity or Godot. If you're going to make a modern game, you're really going to be doing it with one of two approaches. The first is one where you have basically a blank canvas to write to, and you control every pixel, every frame. The other is something like Unity, where you're setting up a scene with objects and enemies that have scripts attached to them to interact in different ways, and then you're letting it kind of play out with the user's input, but you're not personally controlling that main loop that draws each frame. Writing a Game Boy Advance game is different than either of these, and the reason is because the Game Boy Advance is just not that good at software. If we want the GBA to do anything at a reasonable frame rate, we have to get out of software and down to the hardware as fast as possible. To do that, we end up directly manipulating locations in the Game Boy's RAM. For example, if we want to see if the A button is pressed, we have to look at a specific place in memory and see, is that bit flipped? Or if we want to render a sprite, we set some bits in the object memory that says, hey, here's where the tile information is, and here's where the palette information is, and it can put those together in hardware to make a rendering to the screen. It ends up feeling pretty similar to a lot of game development, but it's a lot less safe. If you make a mistake, if you access something that's in the wrong location, your entire game starts acting really weirdly because all of this data is packed really tightly inside of the RAM of the Game Boy. So it's really not that bad, technically, to bring an idea to the Game Boy as long as you're willing to work within the constraints of the hardware. And things do get weird. For example, when you're dealing with Chapter 3. Modern video game sound comes in three forms: the dialogue, the boops, and the bops. Dialogue is anything spoken from a character, boops are things like sound effects, and bops are the music. Dialogue is the hardest one of these to pull off on the Game Boy Advance, and that's because there's no way to fake it. If you want to hear a voice, you have to have compressed waveform audio of a voice. And the Game Boy can actually do this. It can play back a recording of my voice. However, because the Game Boy is bad at software, we can't use any efficient storage medium. So like an MP3 file, out of the question. We have to use audio formats that the Game Boy can really easily convert into actual sound, and those are normally WAV files or PCM files, which are really the same thing. And these raw formats are just big. We can compress them, but then they start to sound like crap. Older devices used to fix this by having hardware implementations of codecs. So to play an MP3 file, you would have a dedicated MP3 chip that is good at decoding MP3 audio. I want to be clear, it's actually relatively common for Game Boy Advance games to have some snippets of recorded audio, and that's completely fine. They're still large, but you can do it. And then we see things late in the Game Boy life cycle, like the movie cartridges, and these were made possible by the hardware getting cheaper so the cartridges could be bigger, and efforts at research and development at Nintendo to make things like MobiClip and other algorithms to compress things that we don't have access to today. And even with all that effort, the quality is still pretty trash, so if you don't want to be thinking, wow, this sounds terrible, it's probably best to avoid dialogue as a whole. Luckily, Super Auto Pets really has just about no spoken words, so we don't have to be too concerned here. And sadly, I think we're going to leave out all of the individual animal sounds because it's just too much to deal with in terms of this demake. Although large WAV files for complex audio clips like dialogue really don't work very well on the Game Boy, what they do work fine for is short sound effects type noises. So for this game, I used an online sound effects generator, and I made a bunch of little ticks and tacks that can be played throughout the game just to give a little feedback as you're doing actions. And then for the bops, there's really one important Super Auto Pets song that we have to try to get in some form. As I mentioned, with dialogue, there's no way to cheat to create what sounds like voices on an old console, but with music, you can, and you can reduce it down similar to what we have to do for images, where we reduce it down to a palette and a bit of data. Instead of storing one gigantic WAV file, we can describe the notes we want to play in the order we want to play them, and then the Game Boy can take that recipe and synthesize the actual noise that you end up hearing. This uses way less space because the sound we're hearing is really inputs to a mathematical formula to generate a square wave or a rest or whatever. You can store way more music using this format, however, you're limited to sounds the Game Boy can create. This type of music generated on chips called chiptune music is a huge area of music, and it's something I'm not even close to good at. But my girlfriend and I did sit down and attempt to recreate the song as best we could with, frankly, minimal effort. With that bit of bops and boops and absolutely no dialogue, we can move on to the final chapter, gameplay. We'll look at two main areas of gameplay that differ from the normal Super Auto Pets. The first is our implementation of the solver, and the second is how we deal with opponents. The solver is the implementation of the logic that says if two teams are competing, they're going to go head to head, have these animations, and then at the end of the day, one of these two teams is going to win. I went through and I defined metadata for each animal that says their traits, and then I also went through and implemented each of their different triggers. Solving a Super Auto Pets game isn't actually that hard, we just have to make sure we're diligent about triggering triggers when they should be triggered, then giving other triggers which those triggers might trigger the chance to trigger and resolve their own action. Trust me, it sounds worse than it is. The hard part about actually implementing this was just the number of animals. Doing anything 80 times is exhausting. Then going and testing that logic to make sure the trigger is actually implemented correctly is just incredibly tedious. I saved myself a lot of time by knowing from the beginning that I was going to need to do a lot of testing of the engine, so I actually set up the code base in a way that it can compile to both a Game Boy Advance game and a separate Super Auto Pets CLI. This command line interface can be ran on my computer, the logic will play out the same as it will on the Game Boy, but thousands of times faster, and I can integrate that with tests in my IDE, so I have this really smooth way to test hundreds of different battle scenarios without ever actually booting up a Game Boy. This command line interface is also incredibly useful for the second part of gameplay, which is figuring out opponents. In the real game, there's a server that has thousands of games stored on it, and it can serve you up teams to act as opponents. We want to do the same thing in our Game Boy game, but without that client-server model. That means we have to have a huge database of teams that are at different turns and different places in the game that you might come up against. This stumped me for a little bit because I wasn't sure how to create all these teams. I know my solver is going to differ from the official one. There's going to be little implementation details that make games play out differently. So I can't even just go like copy and paste teams from the normal game. But this CLI solved this problem too. Using the CLI, I can simulate millions of games where the players are just doing random things. Then by ranking the results of those games, I'll be able to see teams that are more difficult or easier, and I can take a distribution of those to actually include in the game. Probably 1,000 or so teams for each turn, and then if we store those efficiently, they should fit on the cartridge just fine, and we should have a nice big selection of opponents to play against. Once all that was completed, I just went back into the Game Boy version of the game, added animations and some other polish, and we were pretty much ready to go. While I let this run in the background, I want to give you some stats about this game. Over the course of about 3 weeks, I put about 100 hours into making both this video and the game itself. We cover the original 60-some animals, including all the original items. It's not lost on me how much of a blessing it is to get to spend 100 hours building something like this. It's an amazing moment when you get to spend time building something you enjoy. So that leads me to the next part, which is, when can you play it? And the answer is, not yet. I want to make sure, out of respect for Teamwood Games, that they're okay with me releasing this as open source. So if you can, please share this video to them. Make sure they see it. If they get in touch and say it's okay, I will open source the whole thing. You can play the game, mod it, do whatever you want. I'm going to post a Q&A in a couple weeks if we have enough questions in the comments. In that, I will let you know if it's available for download, what Teamwood said. So make sure you're subscribed for that and post questions down below. Would love to address them in the Q&A. But with that, thank you so much for watching, and I hope you liked the video. Have a good day, and I will see you soon.